Happy to see you there. It's a bit early. I know the nights are short at Barcelona, so thanks for being here. I'm Sébastien Deleuze. I'm a Spring Framework core committer. I work at Broadcom in the Tanzo division. And today I'm going to talk about one of the cross-cutting topics I work with a wider Spring team. It's null-safety in Java with two tools, JSpecify and NullAway. I work on various topics with the Spring team, like runtime efficiency with GraalVM or Project Leiden. Recently, I introduced Jackson Free support in Spring Framework 7, Kotlin support, etc. But today, we are really going to focus on how to remove or avoid null-pointer-exception in production with Java. And so we are going to begin by a problem statement. We are going to begin by defining what we want to solve. So it's a very simple example. We are going to start very simple. We have this token extractor API. It takes an input, a string. It returns another string. The basic goal is to extract tokens, and the Java docs say, return the extracted token. So cool. We are just going to leverage that very simple API. We are going to instantiate a default token extractor. We are going to extract a token with any kind of input, get the result, and try to display the length of the token. And here, for some reason, there is no token, because no token has been identified in the input. And you can see we have this famous null-pointer-exception. Here, this is super obvious, super simple. You may have catch it before the compiler or the runtime of the Java program. But in very complex program, you can't escape that. If you don't have any kind of check for that, I guess anybody, even the best engineer, had to face null-pointer-exception, had to basically roll back a deployment Friday night, and you know that's painful. So our goal is to catch this kind of error before we run our application in production, and try to solve that much before. The root issue here, it's not null by itself. Null is cool. Null, we are going to use it as a kind of feature. But here, the root issue, the root sin, is that nullness is implicit in the Java type system. So when you see this API, you can't know if basically the return value will return null or not. The Java doc just says the extracted token. So does that mean that basically the author know that there will be no null return value and don't specify it and you need to believe it? Or he has just forgotten to say in the Java doc that it could return null? Everything is a bit dynamic. So we want to make that more explicit. And in order to make that explicit, we are going to use JSpecify. So JSpecify, it's a project I have been involved in. It's basically a project, a joint effort by big companies and organizations. So Google is leading the effort, JetBrains was part of that effort, VMware, then Broadcom are part of that effort, Uber, etc. And the goal was basically to have various companies coming together and trying to introduce a standard, a pragmatic standard, in order to provide null safety, because there was not really a good solution disponible. I mean, on Spring side, we are using GSR 305 to meta-annotate our nullable annotation for quite a long time, I think since 2017, Spring Framework 5. But GSR 305 is a dormant GSR. It has some drawbacks. There is no canonical dependency. It's a dormant GSR that has never materialized, so we use it because it was the less worse solution, but JSpecify a much better solution, and we are going to see why. The mental model to have is not a two-state thing. So sure, you have nullable, it can include null, and non-null, it will not include null, but the third state, unspecified, which is the Java default, is super important. It's super important because we are not going to change Java defaults. I mean, Kotlin default is non-null. Java default will remain unspecified, and even if you are using JSpecify, when you are dealing with libraries that are not using JSpecify, it's very important to know that those type has unspecified nullness in order to have a good interop between the code that is nullness annotated and the code that is not. So free state, very important. So we are going to add those annotations to make things more explicit because we are in Java, we are not in JavaScript or dynamic languages. We like to define things clearly in our APIs. So we are going to go to our build because we are beginning to add the dependency. So dependency is super simple to remember. The group ID is org.JSpecify. The artifact ID is JSpecify. The version is 1.0.0. Super simple. Apache 2 license, everything is clear, etc. So now we are going to add our nullable annotation to annotate the type usage of the return value. You can see the package here. And you can see in the Java doc that it targets only type use. So it's important, it annotates the type usage, not necessarily the return value or the parameter. You can use it on fields, on return values, on parameters, and even on generic types, which was not possible with JSR305, and even on array and varargs elements. We are also going to annotate our input to say it's non-null, because we want to go out of the unspecified state, so non-null, okay, everything is defined. And we are going also to annotate our implementation, because in theory, in the implementation, I could refine the nullness contract that is defined on the interface, so it's important to repeat that on the implementation. It's not inherited by default. And now our IDE is warning us, hey, you may have a NullPointerException, so I have a signal, and I can basically take care of dealing with that code path, so that's much better. Of course, very simple example, you need to imagine that, and we are going to see that at the scale of Spring Framework, a big library, or your application, because you can annotate your application. So imagine a big project. You will gain a lot of safety by doing that. So you may have some question like, why not using optional? Optional is designed to express the potential absence of value. It is part of the JDK. Why not just using optional? Well, you can use optional, but you can't use it everywhere. Optional is not usable in a lot of use cases. It has some runtime overhead because we are just waiting Project Valhalla for so many years, so we don't have value classes. And so it has a runtime overhead. Maybe later that will be removed, but there is still some other blocking points. The most important one, I think, is it breaks existing API signatures. So, okay, let's decide that we want to use it on Spring or the JDK. Are we going to break all the APIs to change our nullable return values by optional? It's totally not doable. So maybe you could do it in some of your application, JDK, Spring, stable libraries, it's just impossible. The other big reason is that it's not intended for use as parameters or fields, so please stop using optional on those. Check the Java doc of optional. It clearly states that optional is designed for return values, and only for return values. You can have more detail in various blog posts and Stack Overflow answers. And lastly, it increases the complexity of your code base and your API, so it adds a wrapper everywhere. It will basically clutter your code base. So when you want to really express the potential absence of value, it's fine. If that's not on super critical code path, it's fine, but using it everywhere is not really an option. Another popular question I got all the time is, yeah, okay, there is a gazillion of nullable, you are introduced the right one, the golden standard. Are you mad? There is a lot of nullable variants. If you check in your class path, you type @nullable, and you want to import your library, your class, you have a lot of variants. There is Jakarta one, the IntelliJ ID one, the JSR305 one, etc., etc. You may have introduced your own one, maybe. So it's true that there is a huge number of nullable variants, and why JSpecify is better than the others. I think the main reason is JSpecify is just 4 annotations, so you may wonder, okay guys, why have you taken 5 years to work on 4 annotations? It's because it's not just 4 annotations. We have basically defined the semantics, written the documentation, and it takes a lot of time for very different use cases, Google, JetBrains, ours, to to agree on some common specification. And you see the nullness specification that we are seeing there. They are allowing tooling vendors to implement the same behavior everywhere. That means NullAway, IntelliJ ID, and other vendors will be able to implement something that is clearly defined. And you can see it's just for annotation, but it's quite detailed. It's quite complex because defining the semantic of nullness in Java, including for generic types, including for varargs and array elements, believe me, it's very complex for tooling vendors. On usage side, it's reasonably complex. When you are implementing a tool, you need to have clearly defined behavior in order to allow various implementation. So really the key point and the key differentiator for NullAway versus, for JSpecify versus other solution is really clearly defined specification. Okay, we think, so when we migrated a Spring Framework code base to add nullable annotation, we found that we have around 80–90% of the type usages that are non-nullable, okay? So that means that I am going to have to annotate at non-null everywhere, destroy the readability of my code base, and basically, it's not going to fly. So what we want to do and what JSpecify allows us to do is to define the default to non-null, like Kotlin, basically. So you define that on a specific scope, you want the default to be non-null, and you are going to only annotate what is nullable with at nullable. And so this is what we are going to do in our very, very simple example, but think about a much more complex code base. Typically in Spring Framework, and what I advise is to annotate the package. I think it is a right granularity, so you are going to annotate the package with null-mark that say basically, by default, everything is non-null, and if you want to have something nullable, you have to mark it with at nullable, okay? So, at null-marked on the package. By the way, those are the 4 annotations of JSpecify, non-null and nullable, we have seen them. And we have also null-marked, which allow to mark a module, a package, a method, a constructor as null-marked, and you have null unmarked if you want to annotate the package with null-mark and just unmark a specific method, for example. But this third one is very rarely used. We mainly use the 3 first ones. So now we can, now that we have set the default to non-null, we can remove the explicit non-null annotation from our program, and that means that any non-annotated type usage will be non-null, and that will continue to work like previously. So if we check our main, and if we try to pass null here, the ID is complaining, our checks are working because non-null is the default at the package level. It's not transitive for every sub-package. So if you have various sub-packages, you need to annotate every sub-package with a null-marked. But I think this is the right granularity. I don't recommend to annotate the module because in theory, it could concern only the code that is in the module path, not the class path. There is some controversy, so just if you want to have a wide scope for null-marked, annotate the package. That's my advice. Okay, so I think I'm going to learn a few things even to senior developers, at least myself. I was not aware about those Java syntax tricks. And some other members in the Spring team, I won't say any name, but we are not aware as well, even more senior people than me. So let's see. What is very specific about JSpecify annotation is that it's only target type usage. And usually for other variants, they are using either just method parameters or type usage plus method and parameters. Here, we are only targeting type usage, and that means we are relying on the Java syntax specification for type usage annotation. And there is 2 special cases. The first special case is when you have fully qualified types. So let's say we are using java.lang.string, and you see I have an error. Basically, okay, annotation not applicable to this kind of reference. What's that? In fact, the Java specifications say that you need to put the annotation after the last dot of your package, not my fault, not JSpecify fault. This is Java specification introduced in Java 8, just very rarely used. Okay. And same if you have nested type and you want to annotate your field or your return value, you are going to write token extractor.nested, you naively annotate it with nullable, and you are fine, but you are not fine. There is an error because you need to put the annotation very close to the nested type after the last dot and not before the enclosing type. So yeah, that's a bit surprising. There is some reasons because in theory you could have some type usage annotation plus some basically field or method return value annotation, and both will apply to different scope. What I advise is generally to put the @nullable annotation closer to the type. And this is why when we are using the return value, we are putting it very close on the same line. But yeah, Java specification, not our fault. I was not aware of that. Maybe you were, but yeah, that's surprising. Keep that in mind. Okay, we have warnings in our IDEs, and you can go pretty far like that. In Spring Framework 5, basically, with Jürgen and the framework team, we were just using IntelliD inspection plus warnings in order to check the null safety in Spring Framework. That was a bit hackish. Of course, we missed something, so Kotlin people using our annotation were basically creating issues because for them, the null safety was an error, not just a warning. But it allowed to go pretty far, but I think what we want to do is to treat those null safety inconsistencies and errors as some compilation error, okay? So we are going to introduce NullAway in order to break our build, break our CI, make it red when we have inconsistency with the type system. So we are going to add NullAway. So here you can see that I have a warning in my IDE, my build is green, and that's not what we want. We want our build to break, and we are going to break it. We are going to break it with NullAway, so we are going to our build, and we are adding error-prone Gradle plugin because NullAway is an extension of error-prone, an annotation processor created by Google to check your code base. There is also a Maven plugin, of course. You are going to add error-prone core dependency, and you are going to add the NullAway dependency that will extend error-prone and provide the specific checks for nullness. You need then to configure it. So here we configure it for Java compile task, and we are going to disable other error-prone checks because error-prone is doing more than null safety checks. We are going to enable the checks done by NullAway only on @nullmarked scope, here our package, and we are going to turn the warnings into errors in order to break our build and make it red. So we are back in our program. We run again our Gradle build, and then first time we are happy to have an error, yes. And we have a meaningful error with a message that explains what you need to fix. And if you are going to migrate your code base, believe me, you are going to see a lot of those, like hundreds, and you will fix them, etc. So yeah, that's what we want. We want to have a breakage of our build because we are in Java. We like static typing, and we are kind of making nullness part of the type system here. Of course, NullPointerException are not going to disappear by magic. We need to handle the code path where some values are null in order to manage that explicitly. So we are going to modify our example. And so if token is null, we are going to do something like print a kind of message. And in the else statement, in the else branch, we know for sure that basically the token is not null, and so there is no NullPointerException possible by design, and we are safe. So if you see that in the IDE, there is no complaint anymore, and if we build our application with NullAway, our build is green, we are safe. And it's really about dealing with null code path, getting the detection of that early during the build, the development of your application, not in the production, when it's too late and too costly to fix. So by the way, if you need to convince your management, leadership that it's worth, I mean, yeah, the cost of fixing issues very late is very high, and also it's also about the quality and the safety of your applications. JSR305 and various other NullAway annotations, they typically do not deal with nullness of generic types. nullness of array elements, and nullness of varargs. Okay, so we are going to see that. Be aware you are going to see some weird syntax again, so be prepared. But it makes sense when you flip a bit the table. So we are going to enable the JSpecify mode, which is the more advanced mode for NullAway that is checking generic types, array elements, and just more advanced JSpecify mode. For that, we need the latest version of Java because we need some Java-C fixes. You can, of course, define the baseline for your application. So here we want to keep a Java 17 baseline, but we are using a more recent version of Java. A backport is ongoing for Java 21 and 17, so in a few months that should be okay and not required. So we are going to add some array return values to basically play a bit with that. And you can see that I can specify the nullness of the elements or of the array itself, or both. So here, for example, we have a nullable array, but non-nullable elements. Here we have nullable elements, but non-nullable arrays. So you need to get used to this syntax. You need to differentiate the null-safety, the nullness of the array itself, of the nullness of the elements. And so when you have nullable string of brackets, it means that the string element is nullable. If you have nullable of brackets, that means that my array itself is nullable, and you need to differentiate that. And it looks a bit weird in terms of syntax initially, but there is not really other way to express that in a meaningful way. So basically, the nullable annotation is applied to the closer element it annotates. And you can annotate brackets. You can also do the same for varargs. So varargs exactly the same because varargs are arrays. And so you can do @nullable ... and that means that the array baking your varargs is nullable. I'm changing the implementation to do basically to return some nullable elements when I have an empty token, and that's it. Nullness of generics is also specified and supported, and this is maybe the more complex part of the specification. So yeah, generics are hard. Nullness of generics are super hard in terms of spec. In terms of usage, I think that's reasonably usable. So we are going to introduce a wrapper, a bit artificially, but again, it's to simulate a more complex application. And we are going to specify the nullness of the string enclosing type. So we are modifying our implementation to return a wrapper that we unwrap, and here we want to deal with the return value. So if I want to specify that wrapper, T in wrapper can be nullable or not, I'm going to do this kind of thing. I'm going to write T extends nullable of object. That means that when a wrapper is declared, you can either make it nullable or not nullable. So it's pretty flexible. And if you are declaring wrapper here, so here I want to make it nullable. I want to make the string nullable, so I will just write wrapper of nullable of string for the return value. And then IntelliJ ID and NullAway will understand that basically my type is nullable and will do the related checks. I need to do the same in the implementation, same thing. I could override that. And if I go to my main, this is also required. Okay. Okay, so I have defined that my wrapper is nullable. If I would have defined my wrapper as wrapper of just T, since null-marked also applied to generic types, it would have meant that T was non-null. What is cool with those null-safety annotation is that you can consume Java libraries from Kotlin, and they feel like idiomatic because there is an automatic basically interpretation of JSpecify annotation by the Kotlin compiler as of Kotlin 2.1, the current stable version. So how does that work? We have a Kotlin version of our main, and here you can see that I have string exclamation mark. Exclamation mark means that's a platform type in the sense of Java platform type, and that means that the nullness is unknown, okay? So when you are using Kotlin, basically, that basically defeats all the null checks, because you can see Kotlin is not able to see if token is nullable or not. It's unknown, and so there is no issue here that is raised during the compilation, and you will have a null pointer exception at production, even if you are using Kotlin. And so when you are exposing some libraries and some code that is used by Kotlin developers, that's an issue. So if I'm adding my nullable annotation from JSpecify, you can see that here, my token is a nullable string, and then Kotlin is able to detect that in the IDE during the compilation, even if that's coming from Java code. And by default, this is an error, so you don't have to do extra compilation like with the GSR 305. Kotlin compiler, as of 2.1, interpret JSpecify-based nullness inconsistencies as errors. Okay, we are going to talk about Spring, because that's Spring I/O, and I have been introducing that topic with very simple example to just show the basics, the foundation. Now we are going to see how we are going to leverage that with Spring. A few months ago, I shared this message on social media. I merged a huge commit that changed basically the Spring Framework code base from GSR 305 meta annotation to JSpecify. So basically, I had to change most of the code base to do that. And yeah, maybe people were just excited about the big numbers, but at least it provided some visibility to JSpecify. So we are going to see how to leverage null-safety with Spring, because the goal that we have is really that we want to annotate all the code base, including the generic types, the args elements, to provide full null-safety. Even if you are not using nullness annotation in your application, you will automatically benefit of that because your IDE likely know to interpret those annotations. So let's see how that works. We are going to add a Spring dependency, so we are going to use a very simple example. We are just going to use a web client, an HTTP client, to do some stuff. So we are adding Spring Web as a dependency. We are using Spring Framework 7 because those annotations based on JSpecify are introduced in Spring Framework 7. That will be available with Spring Boot 4 in November. And we are going to just use our annotation, and we don't even use JSpecify in our app, but we are going to leverage some API from Spring, which are using JSpecify. So we specify a base URL with some fake domain. And we are going to get the body of a REST endpoint. So we write client.get, because this is a get request. We are going to specify the URI. So here, may be empty, okay? Okay, we retrieve it, and we turn the body to a string. If you check the body method, you can see that we have annotated it with nullable, because if there is no body, basically the return value will be nullable, and so your IDE and NullAway and any tooling that you may have will be able to help you to handle that correctly, because you may just do something with body that is not null safe. Typically do something with the body and call a method or whatever. And here you are warned by the IDE, by NullAway, and the whole Spring Framework code base is annotated with JSpecify annotation. If you are using something that you know, return a body, it could be a bit painful. So here what you can do is to use methods like objects.require_non-null to express the fact that you know this endpoint returns something and you don't want to be bothered by some warnings, and NullAway and CDGID will basically recognize that. If you want to do something else, like throw an illegal state exception, for example, with some methods that we provide in Spring with assert.state, here that's a bit different. We want to express that after this invocation, body is not null. How do we do that? We do that with a special contract annotation that we have borrowed from the JetBrains people, and that basically explains that when the expression is false, an exception will be thrown. That means that after the invocation, we know for sure that body is not null. So This contract annotation allows us to express some additional semantics. So I need to configure NullAway to say my custom contract annotation is the Spring one, but that allows us to be more expressive, and we are currently annotating various methods in the Spring code base in order to express those contract annotation, mainly in the util classes. Okay, so we see that it's building correctly. We may add more annotation to JSpecify, because JSpecify, the name is pretty broad, because it took 5 years to release 4 annotation for nullness, so we wanted to just ship 1.0, but potentially later there may be additional annotations. For example, check return value kind of thing. It could be a good fit with JSpecify. This add contract method annotation that we have to provide within Spring, which is using this strange expression language, maybe we could have a bunch of annotation in JSpecify that will be available for everybody, understood natively by all the tooling that deal with that. So the JSpecify working group is pretty defensive on not introducing fancy, crazy annotations, but for those use cases, we may potentially introduce something in JSpecify 1.x or JSpecify 2.something. Okay, now you are going to have some special case because, life is complicated. So lazy initialization, let's see what we have. We are going to create a new class, which is basically lazy init bin, and we are going to implement initializing bin that will basically allow you to implement after property set that allow to do something at some point in the Spring lifecycle. So we are defining a field, and we are going to add a non-nullable method that returns the value initialized in this field. Okay, so let's see what we have here in terms of warning. So you see field, we have an error, a warning here. Our compilation will be broken because field is not initialized, and it's not initialized by, it's not annotated by @nullable. So here we have a null-safety inconsistency that we need to fix. Okay, so I annotate my field with @nullable. All good. Oh, damn. I have an error on the getField implementation because now my getField annotation, my getField method thinks that it will return something nullable. Even if in Spring context, I know that Spring will initialize that, and in practice, getField, I don't want to bother people with something here. So the current workaround is to use some special suppress warning like nullAway.init that express that this field will be lazy initialized later at some point, and that I don't want to consider it as nullable. And so when we build our stuff here, you can see that it works. So there is not really a nice way to solve that yet in Java. Stable values, that is targeting Java 25, is a JEP that will potentially solve that. Stable values allow to leisurely initialize something, have some JVM optimization, and have some semantics that basically ensure that when you get the value, it is initialized. So I think this stable value thing that is currently using wrapper, so the syntax is not crazy exciting, is the right way to solve this lazy initialized thing and get proper check by tooling. But for now, we live in the present, so please use suppress warning, nullAway.init, or there is other alternative way to fix that. But there is some cases like that where there is not really a proper way to solve that, and so that will push you to use constructor-based initialization. I mean, this is going, null-safety, introduction of null-safety is going to push you to use a better design for your classes, for your bins, because if you are doing constructor-based initialization, you know the nullness of your value, and so everything is safer. There is an ongoing effort to provide the null-safe APIs in Spring Boot 4. In fact, a lot of people in the Spring team are working on that, and so it's maybe the biggest new feature. I mean, this is my preferred new feature, at least, of Spring Framework 7, Spring Boot 4, and all the other Spring projects. We are working on introducing JSpecify annotation in the whole portfolio. That means that it's not just Spring Framework and Spring Data that basically did that initially in the current generation with JSR 3.05. Spring Framework, Spring Data are migrating to JSpecify, but also Spring Boot, Spring Security, Spring AI, and other projects are going to introduce JSpecify annotation to provide Spring API null-safe everywhere. At least we try to provide everywhere. I don't promise that 100% of the API will be done when we will release Spring Boot 4 in November, but that's a major effort that involves all the Spring committers, and that's huge because we are not just going to throw some annotation and pray. We are going to check that with NullAway, and believe me, annotating big code base is very useful. I think that's very valuable, but it's a lot of work, so thanks for the Spring team to work on that collectively. That's a massive team effort, and I'm super happy about that, and I think that will deliver a lot of value to both Kotlin and Java developers. We will push, that's just a recommendation, but to use JSpecify annotation for annotating your applications, because if you are using Spring Framework that is annotated everywhere, if you are using JSpecify annotation in your application as well, that means that except some third-party library invocation, you can guarantee to your boss that there will be no NullPointerException in production, and that's a game changer in terms of safety, in terms of checking errors before and making your application more safe. So up to you, but we think that could be a good idea, and we have already a lot of big companies that have expressed the intent to basically annotate their own code base with that. Of course, if you don't annotate your code base, you will still benefit of the null-safety that we have on Spring side, because you will have some warnings in your ID, etc. But the benefits are even better if you annotate your application. And what I like in this thing is that we turn collectively the billion-dollar mistake. This is a name that the creator of Null is giving to this thing. And in fact, I think this is more a trillion-dollar mistake, because the cost is crazy, crazy huge, into a zero-cost abstraction, a bit like Rust is doing, allowing to express the potential absence of value. So we turn a drawback into a new feature, and I think that's pretty exciting. And it's even more exciting that after many years, we see some move on Java side in order to introduce null-restricted types in the JVM, in the JDK. So it's pretty interesting to see that it's coming from the project Valhalla angle. So basically, the reason why it has been introduced initially, it's because they need non-nullable field to do some optimization, like remove a bit and get memory alignment and get optimization from a runtime efficiency perspective. So what I have advocated here was mainly about safety during the build time. What we will see later in the JDK is that a null annotated code base will work faster, will consume less memory than a regular code base. And they are targeting potentially not just annotating the field, but also the return values, the various types. So same scope than JSpecify. The big difference is that they are not going to change the default. So basically, the current plan is that foo question mark will be nullable, foo exclamation mark will be this null-restricted type, so the equivalent of @non-null. And it's pretty clear they are not going to change the default. They don't want that you need to introduce a flag like .NET did, or annotate your package to change the default. So yes, you will have to use exclamation mark everywhere in your code base if you want to use that. But maybe we will have some bridge between JSpecify and that. Potentially, and I don't say we will implement it, but potentially we could imagine a kind of preprocessor that is turning your JSpecify annotated code base, when you have defined the default at package level, to some bytecode that will basically deal with that. So a natural translation from JSpecify to the upcoming JEP, and so you get the best of the two worlds, and I think there will be something like that. But yeah, the Java platform team is working on that, and that's pretty cool. And I hope they will use all the learnings from JSpecify. Last slide is that we are looking for contributors on NullAway side. I get regularly people coming and say, how can I help Spring? I would like to contribute, etc. Nowadays, one of the biggest needs is on NullAway side, because more and more people are using it. Manu, the project lead, is basically asking some contribution, and basically the NullAway community would welcome some people. So if you are interested into helping the wider JVM ecosystem, if you want to have a new playground, if you want to do some meaningful open source contribution, go to the NullAway GitHub. At the bottom, there is a link to their Discord server, and you can basically discuss with Manu. He's a super kind person, super good project lead, and it's an annotation processor, so basically you need to learn a bit of low-level Java, Java CAPI, etc. But that's super useful, and I think that's very interesting. That allows you to learn very how Java works in the type system, etc. So if you are ready to contribute on open source, feel free to ping Manu on NullAway. He's looking for help. Thank you for your attention, and if you have any question, I can answer. Thanks.